In this video, we're going to be utilizing night lights, or the Earth at Night flat maps, and these were produced in 2016 and 2012, and NASA's been organizing this project. It's from a particular satellite that is able to sense light at night, the luminosity of light, and it translates into a pixel, a raster pixel, that holds a value of brightness. So we're measuring our values within the raster thematically to light, and it's the greater that the value is, the greater that the number, the integer is, the more brightness there is in the pixel. We're going to be using the 2016 and also the 2012. We're not going to use the true color or the full color. We're going to be using the grayscale version. So here it is, the grayscale version of GeoTIFF, 3 kilometers, 64.4 megabytes is the download size here. And you can also do this assignment a second time over if you'd like to, using real high resolution imagery. So this is 500-meter imagery. That's much better than the 3 kilometer cell size that's offered in the one that I'm going to demo here. And the one that I demo here is perfectly fine for your assignment, but if you do want to really focus in on one particular region, say one country or a certain region, then think about doing the higher scale imagery. And in that case, you would just download one of these tiles, or if your region falls within one of these tiles. For instance, India looks like it falls pretty much within C1 here. Okay, so I'm going to go ahead and show you what I've downloaded these tiles that I'm going to use. I'll show you what they look like in the folder, and then I'm going to go over the actual steps that we're going to do together. So I have a folder set up called EC4, okay? And in this folder, I have my 2012 to 2016 lights. So that's what I just downloaded, and we can see those download. When they download for you, they may look slightly different. It may just be just one file. We also have Natural Earth Populated Places and Natural Earth Country Admin. And these features we can use to just add some value to the final raster result. So give us a little context of, here's a country's borders, and if you want to use the labeling out of the populated places, that would be a nice approach also. So just give you some context for vector features to overlay to your raster base if you'd like to do that in your final map. So let's go through the steps that we're going to do here. So we're going to download our data, which we've essentially done. And then we're going to look at the raster properties together. We'll review the cell properties. Then we're going to perform a map algebra equation. And we're going to use a tool set called Minus that's located in the Surface Analyst extension, which you've already had some practice with in the assignment itself. And this is just a quick way to set up this equation. We want to subtract the 2016 values from, or we want to show change between 2016 and 2012 by subtracting 2012 from 2016. We're going to look at the raster output, what we get back from that equation. Then we're going to get into symbolization. So when we symbolize the raster, we don't actually change the raster values, but we do assign different colors, different options for what we're actually seeing on the screen in terms of raster values. And this particular data set comes from NASA in a projection called Plate Carré. And with this particular projection, it deals with linear units in a very specific way. And for your final mapping, we want to change that. And we haven't really got into map projections yet, so we're just going to do kind of an on-the-fly option without spending a lot of time with this particular feature or this particular raster projection. But I'll show you how to do that first. And then we'll get into actually doing the color ramp. We're going to stretch it. We're going to do a legend. We'll do some different options for producing a legend. And again, if you want to do this for a larger scale tiled version, and your geography of interest is within one of those tiles, that's a good option just to get some more resolution out of the raster itself. Okay, to get started, we just need to make a connection. So I'm connecting here to the EC4 folder, which is extra credit 4. And if I open it up, I want to be working with my two rasters. So I'm going to let it open itself up. And the first one we're going to put in is 2012. And here we can see it. and then I'm going to put in 2016 on top of it. Just drop it in from our catalog. And then I can toggle on, toggle off, and we can see that there's a change in the pixels here. And where we see a change in the bright pixels or the more white pixels, that's where we're actually showing a gain in luminosity in 2016 over 2014. So within 4 years, we're seeing quite a bit of change. And this change is very dramatic in India. So let's zoom into India. So if we, at this scale, let's just look at it together. So if I take off 2016, that's what it used to be like in 2012. You can see just the massive increase here in terms of luminosity. And we can even get even closer into the pixels and start to think about it, the change at the pixel level, which we'll do right now. So although change at this scale is really interesting, as we get into our calculations between the rosters, what's really critical is at the cell level. So what I'm going to do here is I'm going to just bring my standards toolbar to the middle, and I'm going to line up a pixel with this particular standards toolbar. So there's a lot of change that's happening right underneath it right now, so I'm just going to zoom into that area. So this is obviously a city center, and then in 2016 we can see that it's just filling completely in over here. So I'm going to get on the edge of it, and I see some pixels changing that might be good for us. So right here I'm going to zoom way far in and line it up. Okay, let's do this one right here. So this particular cell I'm going to use as my test. So there it is. So in 2012, the value was 61. Its luminosity was an integer of 61. And then if I put on 2016 and sample it, make sure I got the right one here. Okay, that was 2012, that's 61. This one's 169. So I see almost 100 increase in value. So when I do the calculation, I would expect to see this new cell right at this location change accordingly. Now let's take a look at, before we get too much further, at this file type. So we always want to understand what our actual product is, our roster product is. All the values are being held in the cell format, as we can see. And if we go down to properties, we can see its cell size. This is being measured in decimal degrees right now, so it's a little hard for us to understand, but we know from the original product description that it was a 3 kilometer product. So height and width are both 3 kilometers, so it's a pretty big cell size. So it's covering 3 kilometers square on the Earth's surface. So if you were to use the other product that's 500 meters, that's going to get you a much tighter cell, or one that has a lot more resolution. It's an integer, so the pixel type is an integer number, and it's unsigned, and it's 8-bit depth. Okay, so it's not going to allow a lot of variance. And it also has a spatial reference. So here we can see its linear unit is 1 meter, and its angular unit is 0.01. Okay, so let's do this. Let's go ahead and run our calculation now. And to do that, we can do a quick search for minus. So if we just go to our search, which is right next to our catalog, and just type in the word minus, it's going to bring us to some options. And this is under the Spatial Analyst toolset. If I click on that, if you click on minus and you don't get the tool showing up, it means that you don't have, under Customize Extensions, you don't have it clicked on, Spatial Analyst clicked on. So you want to make sure that you have it clicked on. So go into minus. You can also do this in the map algebra calculator, but I'm not going to introduce that in this video. I'm just going to use this interface right here. So the way that this works is we want to subtract, we want to start with our first roster that we're going to subtract something from. So in this case, it's 2016. We're going to subtract the first input, or subtract the second input from the first input. So it's 2016 on top, 2012 on bottom. And I'm going to name it something that makes sense here. So I'm going to call it difference underscore 12 to 16, just so I know. And I'm going to send it to the default geodatabase, that's fine, and say OK. I'm going to keep the same position on the screen here. So when we get back the result, we can just check this to make sure that we got it right. So remember, we checked this cell in 2016, and it was 169. Let's check it again. So that cell is 169. Now, let's come over and check it the pixel value is 108. So it's the difference between 169 and 61, and that's correct. So we know that it ran it correctly. And of course, it did that math on every cell through the roster. And we're way zoomed in right now, but if we zoom back out, we're going to be able to see our results. So let's go back to zoom to layer. And let's click off our other products. We don't need those anymore. Here's our result. So the grays, the middle grays, these are no changes. But our blacks are where we lost light, and our white is where we gained white. So if we look through our roster here, we know between 2012 and 2016 in Syria, we had a huge amount of light loss, and we can see it very dramatically here. And then, of course, around the edges, we can see gains because populations were going to those locations around. And also in India, look at the change in India. It's really dramatic. So we can kind of explore the world through the highs and lows of luminosity between 12 and 14, 4 years, quite a bit of difference. So our final map, what we want to do is we want to show this difference dramatically. We want to really separate out the gains from the losses. Right now in grayscale, it's a little bit boring. So let's get set up for doing that. And the way we're going to do that, we really would also like to be able to work with vector features to kind of give some context to what we're seeing in the roster values. So let's go ahead and work that up. The first thing we need to do, though, is I mentioned that there's a projection issue here, is that if we look down on the bottom and we kind of use our mouse and roll around, we would expect to see a change in decimal degrees, and we're not seeing that. That's because the units being measured right now are so small. And what we need to do is just do a little, I'm not going to get into the projection issue too much right now, but we do need to do this if you want to proceed to producing your final map using the natural earthwork. And the way that we can do that is we're going to go to Arc Toolbox, and we're going to go to Data Management Tools. And under Data Management Tools, under Projections and Transformation, we want to just quickly set the projection to the natural earth features as opposed to what it originally was. And we can do that through Define Projection. And we need to go find our feature, or our roster, which is difference. And it gives us a little warning. It says, listen, you're already defined as a projection, and I know that. But what I want to do is I want to override this particular projection with the other features, the projection of the other features. I know the other features are in WGS 1984, so it's not a big change. If I go to my Add Coordinate System up at the top and go to Import, I can go into my folder that I've organized under folder connections, and I can point it to the natural earth data. So either one's fine. And I'm going to go into the 100 million admin and add it. And you can see it comes in, it's WGS 1984, and say OK. And then it takes effect and say OK. And then it'll run it. So it's not changing the location, it's just putting on it's redefining the projection. So difference 2016 now is in the same projection as, or I should say the same coordinate system as the natural earth features. So let's go ahead and start working with everything outside of this space that we've just created. We did the transformation at the cell level, so we're all set, and we know that we have difference 12_16 sitting in our default geodatabase. So what I'm going to do now is I'm going to go to New and make a new mapping session here. And the first thing I'm going to do is add data, and I'm going to go to, let's go to default geodatabase and find our difference. So it's difference, this guy right here. And I'm going to add the pyramid, say yes. And now as I scroll around, you can see that my decimal degrees are something that makes much more sense in terms of latitude and longitude. It's not that teeny tiny value anymore. And importantly, now I can drop in, if I go up to admin boundaries, let's drop in the 50 million. I have a nice context now for my map to start developing this. So let's do this. Let's take out the fill color and just have a nice kind of somewhat neutral edge. And let's also do this for the map frame. Let's make the map frame, I'm in data view right now. I'm going to kind of clean this up a little bit. 1 second. Let's go into our layout view, and I'm just going to set this page space to a tabloid size, I think. I think I might have a portrait actually. So I'm going to have 11:17 portrait and say OK. And I'm going to bring it full scale here. And I'm not sure what country I want to work with just quite yet. I'm going to go to Properties, and I'm going to make the background black so it's very dramatic, and say Apply, OK. You can choose something else if you'd like to. We just want to have some color background besides just white. And now I'm going to go back to this view, to data view, and let's go into India and take a look here. So with India, I'm going to make my outline color just a little bit bigger. There we go. So I can see it. Okay, so what I want to do here now is I want to actually separate out very visually my gains from my losses. Right now they're kind of jumbled up between whites and grays. And we can see some of these are very close to the flat gray, which is, if I use my information tool, let's click off that for a second. These are my 0 values. These are values that did not change. So there's a lot of this that I need to deal with. And then also these grays on the edge, these differences are just maybe 1 or 2. They're either a minus or a plus. It's my blacks that are the big losers and my whites that are the big gainers. So you can see the white pixel values can go, here's some 33s, 48s, all the way down to 17 here. All right. So what I want to do here is I want to actually start dealing with visual representation of the roster. So I'm not changing around the property values at this point. In this particular roster, we have a low of -255 and a high value of 255. All we're doing is kind of painting these pixels based on their values. So the value of the pixel is going to drive the color, and we do that in symbology. So it's similar to doing our work with vectors in that we actually go into a symbology dialog, but we're going to be doing this at the cell level. So it's not applying the symbolization to points, lines, and polygons, but to actually cells. And I'm currently in a color ramp that just goes, it's a grayscale color ramp, and I'm in stretched values. So I'm going to go find one that makes sense. And one that's really good for the high and the low here is this cyan blue and then kind of a purpley color. It's about the 10th one down or so, maybe the 12th one. It's this one right here. And if I say apply OK, it's going to stick my high values in the purple color and my low values in the cyan. I want to flip that around. So I can go to Properties and actually click on Invert. And it's just going to flip that color ramp around. So now my high values, my gains, are that blue color. And that's for this particular map. I think I want that. Now I have, if I zoom all the way out, so zoom to layer, I have this blue that is the dominant color. I want to get rid of that. That's in the middle. That's a 0 value. And the way I can do that is set that value, which is basically the background value. Click on that. I can set that 0 to no color. So I'm going to do that and apply it and say OK. And so it goes away. So now I'm starting to get into something that's much more dramatic. Even at this scale, I can see these pockets of big gains, which is the cyan color. And then interestingly enough, there is a lot of loss throughout the roster set. And we can check this because we know in Syria right here, this region has seen that dramatic light loss or luminosity loss. Let's go back to Properties now. And we're going to kind of clean this up a little bit. So we have on the edge of each one of these extreme colors, the cyan and that really vibrant purple color, we have a lot of values that are right at the edge of these two extremes. And what we can do is we can push those values. We're not actually changing at the cell level. We're not changing the value. We're just changing its appearance. We can kind of push them into the more extreme colors. And there's two ways to do that. You can do it through standard deviations, and you can work with the number. So we're pushing values differently based on what you enter in here. So 4 gives me less. Now if I go to 1, it's going to make it a little bit more dramatic. Percent clip really works well in this situation, so we can stretch it by a percent clip, and even at a minimum and a maximum of 2, that should work out pretty well. So apply it and say OK. And now what happens is that all your gains go to that high cyan color, and all your losses go into that purplish color. So now we can kind of zoom back out. We can really see in binary dramatic fashion here our gains and losses. And it's pretty interesting to see the pattern is that there is a fair amount of loss that's taking place across the 2 years, but then there's also these really interesting gains that take place. This is close to Chicago, and there's a highway that's gone in right here, where I think this is the 90 freeway, I believe. You can see it as a line coming across here. That's a big gain right there. We can go down to, it's really fun to kind of explore this result. We can take a look at the Gulf of Mexico here, and these pixels that are off the coast, let's put on our actual natural Earth edge. So these off the coast are oil rig pads that are flaring, and so we see a lot of losses where some of them have gone dormant, but then we see gains mixed in also. So those are new facilities that are coming online. So it's interesting to see which countries are gaining quite a bit of luminosity and which ones are losing. So it's up to you kind of how, if you want to focus in on a specific region. And if you were to do something, say at a scale like this of 1 to say 20 million here, then heading over and getting the 500 meter product might be a good bet. It'll give you a lot more resolution and you can see the pattern much more clearly. Okay. Now let's talk about the legend real quickly. So if I wanted to produce this map, let's say I'm just going to, for purposes of the tutorial, I'm going to go to Syria and zoom in to that region. So say I wanted to make a map just of Syria here, and maybe I don't want to have it be full bleed on the bottom. Maybe I want to do something like that. So I have some white space here to put a legend. If I just drop in this legend right now, based on the color ramp, let's do that together. So if I go to Insert a Legend, and I put in my difference, it's going to give me those middle values that I don't actually see in the map. Really what I want is I just want 2 colors to be shown in the map. So a way to get around this is we can actually bring in another instance of the same roster, which is going to be difference. Let's see if we can find it. It's in on top. And then what I can do is go to Properties, and I'm going to change that color, or actually let's go into Classified. So not stretched, into Classified. And under Classification, I want, well, let's change the color first. So we're going to use the same ramp. So there's our colors. And I just need those 2 colors. So what I can do is just go to Classify 2, and I need to set up a break that's going to make sense. So in this case, let's go to Manual. So everything that's in the low values is going to be 1, and then anything that's going to be a high value is going to be, so it's -1 and 1. Say OK, that should work. Say Apply, OK. So that gives us 2 values. The problem is that we're flipped upside down. And the way that we can solve this is if we go back into our colors, and you can actually pick out the color property. So in this case, we can go to, again, let me explain how I'm doing that. I just click on the color in the table of contents, and then go to red, green, blue. And so that cyan color is 0, 245, 245. And the other one is red, green, blue, 245, 0, 245. So I can just jot down those 2 colors and just redo those. So my cyan now is going to be 245 on top, 0, 245. Okay, and this guy was red, green, blue, 0 on top. Kind of a quick and dirty way to switch this around. So now, if we just need to check it. So our original symbology is loss of the purple color, gains of the cyan color. And here, same difference. Loss is the purple, cyan is the gain colors. And then what we do is we just go to our legend. Okay, so that's in our legend now. And we can just do a, before we do that, let's change in our table of contents what these represent. So here it's going to represent a loss, and then it's going to be a gain. There's lots of ways to talk about in the legend. This is part of the legend design, how you would contextualize what you're actually showing on the map. So I'm just going to say 2012 to 2012 to 2016 change. That's not descriptive enough, but it's good enough for what we're doing here. Now what I can do is go over to my legend, and now I can just convert this to a graphics, and then I can, go into my legend now and ungroup things, and then start picking it apart. So I can ungroup that and delete it. So kind of delete this till I just get to the point where I just have what I want. And then of course these I can move around if I want to. I can change the font sizes, but then importantly this gets me to the color that I want. And since we're just doing a binary gain and loss map product here, this works out pretty well. And then of course as soon as I change it to a graphic, it's disassociated from the original feature that's in table of contents, so I can just remove this and my legend still is perfectly fine here. Whoop, I just made that too small. And remember, with as soon as you get into a graphic, any changes that you make are going to be very permanent changes. So be careful as you're doing this manipulation, this conversion from a live legend into a graphic. It's going to give you some freedoms, but then everything you do is going to be somewhat permanent. So just be aware of that. So at this point now, we have the makings of a final map. So I would need to go ahead and develop my legend further. I have the colors correct now, so I know that my gains are that cyan color and my losses are the purple color. Through the stretching, we've been able to push our values to the edges in a very dramatic, visible way. I might want to put a scale bar in, a north arrow. We want to keep, since this is a thematic map representing gain and loss, the whole point of the map is thematic, and we don't need a lot of reference features. It might be nice to have the natural earth boundary here, the country boundary. Also, if you want to bring in, if you add data and go to folder connections, populated places, okay, that's going to give you your capitals. So you can make this transparent if you wanted to. Let's make it a color right now. Let's make it a yellow. So if you wanted to zoom in a little bit further and actually have names of locations, if we go into the attribute table here, we can see all the names of the capitals. So there's a lot of labeling opportunities here if you wanted to label the map further. And we've had practice with that type of work in class 2. So at this point you should know how to do simple variation and develop your labels from your points features on top of a roster base. So again, this would be your roster base. You could also do a map insert if you want to. You could also show it at a completely different scale. So maybe you do want to be out at, say, maybe a 50 million scale here. Really come a ways out from the roster and do something like this. That's a possibility too. So if you do the extra credit, good luck, and hopefully this sets you on your way to understanding how we can do some essential math between two rosters to develop a really interesting, important finding. In this case, the difference between those two rosters in terms of luminosity.